Okay, so for this question, I have a coin is flipped repeatedly, coming up with heads and tails with equal probability. Okay, so all flips are independent. Okay, that's great. The flipping continues until tails is flipped twice in a row. Let f be the total number of flips. So in part one, we're asked to calculate the expected value of f. So how we're going to calculate the expected value is that we kind of just see, essentially, we just think of the problem as like a recursion to find expected value. So we have two cases. If we roll heads, then basically the expected value would just, we take one turn to roll the dice and we're nowhere close to getting it from the first state. So basically that's not having nothing and we have to roll again and that would just be the expected value. And if it rolls tails, then we have one half of a chance that we roll tails again and the game would end, and one half chance that it ends lands as head and we're back to square one. So then essentially we can write the equation as such. We have our E of x is equal to one half the probability that it takes one turn plus E of x plus one half the probability that we're going to roll, so then one half um, that ends the game, and the one half that it continues, and we're back to EX, and then it takes one turn. So then I simplify this, and I get that E of X is equal to 6. So my F is 6. Okay, part two, I technically started off thinking that I could write it in terms of expected value and open it like that. But that method didn't necessarily work out because I just got random things. Like my probability is just not, I can't calculate it. That's way too difficult. So what I try to do is I use the law of total probability to partition it by the first two flips. Then I did HH, HT, TH, and TT. But then I realized when I expanded this thing out that I have HH and TH would be all ending with H, so then it would be one half. But I struggled with the case of HT. I don't know how to write this. This just doesn't work out. So then I left a question mark. So I'm gonna have to repartition that in terms of just H, TH, and TT. This way, basically, when it's H, I know the probability of PH, and then when it's TH, I know that, and then when it's TT, it ends. So that's much better than the thing from before. So I can know that my as I partition this thing, my g of fs is equal to the first thing, the expected value of that, which is basically if I have row of heads, then I take one turn, which would be s, and then I'm back to square one, so that would still be the generating function. So that's s times g of fs. And then my probability of rolling a heads is one half because it's given. And then the same over here with the expected value of this. Basically, I take two turns to roll th, so that's why it's s squared. Then I have the g of ss because I rolled a heads in the last one, so I'm back to square one as well. And that happens with one quarter probability. And then in the end, if it's TT, then the game ends with probability one quarter, and I take two turns, so it's s squared. So that's my function. And I just rearrange it so that I get this expression over here. And I made a stupid calculation error. Like basically, I wrote down the wrong thing. Somehow my brain wasn't working. And then I wrote down it should be 1/4. But like I wrote 1/16. So then that made the calculation a little wrong. And in the end, I was able to simplify it to this. Technically, I simplified it to that thing over that expression over here, which I crossed out, which was not right. So everything that followed this was based on this generating function, so that was not right. That was the second part, basically just finding the generating function. Um, yeah, basically, I somehow did some wrong calculation, so that was what happened with my thing. And then in the third part, what I should have done is because I didn't look back at the thing, I just used whatever I had. Then I got everything else wrong. But the idea is the right thing. So the variance is just essentially um, the taking the generating function, taking the second derivative of that, evaluate it 1 plus evaluate first derivative at 1 minus first derivative squared. So that's how you calculate variance. And I just differentiated the g and g, but I used the wrong function over here. I used this value, which was wrong. This value was wrong. So that's why this thing was, everything over here was wrong. But the idea was right that I should have used this expression and I should have gotten a value. So then I redid the calculation over here. I just wrote it down and I got that my variance is equal to 22. So that's kind of like how I did it. But Yeah, definitely I should have used this expression in part three so that I wouldn't have gotten it wrong. But the idea is still the same. And there's one other thing that was I should have caught on earlier before even doing G double prime is that in G of prime one, like I got 3/8 as the answer. That should have already been a red flag screaming at me that it's wrong. Because G prime of one is equal to the expected value, which I calculated earlier as 6. If it's not 6, which in this case it is not, then it basically tells me that I did something wrong. Either my expected value is wrong, or in this case, my generating function is wrong. So yeah, I should have definitely caught on, but I just didn't realize that I made these errors, like a silly error in like the expression, and that caused everything to kind of collapse. Okay, that's it for today.